Hi everyone, my name is Omi and I'm a pre-med student. This is part 2 of our MCAT seminar series covering memory and the study tool Anki. Let's get started. In part 1 of the series, we went over the preparation and planning stage of the MCAT. There's a video recording of the talk on the Pre-Health Professions Club GroupMe, so please check it out if you haven't already. You can contact Moyo or just ask about it on the GroupMe. Before I get into the nitty-gritty of using Anki, I wanted to discuss how our memory works and how you can effectively apply it to the MCAT. I'll share a few useful resources and tools for memorization. I'll probably split the Anki tutorial into 2 parts as there's a lot to cover. I'll walk through setting up the program, how to use the various card types, the best practices for reviewing and making cards, and all the shortcuts that will save you a ton of time during your review. These topics are extremely useful for this exam, but can be broadly applied to anything that requires memorization, like the classes that you're taking right now, language learning, anything really. I wanted to start by going over a few important memory concepts. You're probably familiar with the concepts of short-term and long-term memory already, but it's really important to reinforce how we store information. When you first read something, it gets stored in our limited capacity short-term memory. Short-term memory is very volatile, so without reinforcement, we'll quickly forget what we just read. Long-term memory, on the other hand, is theoretically infinite and can last a lifetime. For example, it's likely that you'll never forget the letters in the alphabet. How did this information become so ingrained in your memory? Well, at a certain point, everything we know started as a short-term memory. Let's look at a graph to better understand how we retain information. The red curve here is called the Ebbinghaus forgetting curve, or the memory retention curve. It shows how our ability to recall information decreases from the moment we learn it. Another name for forgetting is extinction. But how do we prevent extinction? By reinforcing the material after we learn it. The green curves represent relearning. You can see with subsequent reinforcement, the slope of the line flattens near full retention. We have reinforced ideas like the alphabet so often that it essentially achieved 100% memory retention. The general term for this is maintenance rehearsal. When we test our recall at specific intervals, the effect is called spaced repetition, and is the cornerstone of active learning. We just saw how we can use spaced repetition to convert short-term memory into long-term memory. But there are also several ways we encode information into our memory to facilitate this conversion, making it more salient and retrievable. Memorization is not just about repetition, but how well you encode the information. There's visual, acoustic, elaborative, and semantic encoding, each with their own half-life and effectiveness. The most effective form of encoding is elaborative, which associates information with something we already know. The least resilient form of encoding is visual, though combining these encoding methods is additive to memory retention. There are also different kinds of memories. The 2 biggest divisions are declarative or explicit memory and non-declarative or implicit memory. Explicit memories consist of those memories that require conscious recall and can be further divided into semantic and episodic memory. Semantic memory has to do with the meanings of concepts, and episodic memory concerns our life experiences. One of the ways we can encode information semantically is by relating it to our own lives in a phenomenon called the self-reference effect. The second kind of memory is implicit memory, which does not need to be consciously recalled. This includes procedural memory, or skills like riding a bike, and priming, which involves one stimulus affecting the perception of another. An example of priming is if I say airplane and then say wing. You probably imagine an airplane wing rather than a chicken wing. Every type of memory and encoding will be used in some way to maximize your performance on the MCAT. Explicit memory will help us memorize the facts we need to know. Implicit memory will help us associate cues to trigger memory retrieval, but it will also allow us to build up our test-taking skills. There are a few techniques proven to improve memory, some of which you've definitely used in your classes before. The first technique is a mainstay of math and science, and that's mnemonics. Mnemonics are memory devices that associate items on a list with words or ideas. One example is PEMDAS in math for the order of operations. Mnemonics are probably the most important memory tool at your disposal. One thing you need to realize is that you should make your own mnemonics. Remember we talked about the self-reference effect? Well, mnemonics will be most effective if they're related to your experience or your unique way of thinking. The more you practice making mnemonics, the better and faster you'll be. Also know that there's no such thing as a bad mnemonic. You'll even remember those. Mnemonics can be made better by using exaggerated or surreal imagery, ideas, and sounds. You can utilize all the methods of encoding to make your memories last longer. My only warning is not to use the same kinds of ideas for multiple mnemonics, as you might get mixed up and recall the wrong one. The PEG word system is a memory device that associates numbers with related words to remember the order of items or steps. It's a little difficult to explain, but you can use this technique to remember a series of steps in a process by associating each step with a different word or idea. The end of one idea triggers the next one. You can even use this technique to memorize long words, which will become helpful with medical terminology. Another memory technique is the method of loci, which you may have seen dramatized in TV shows as a memory palace. This is where you associate information with a location in a place well known to you. For example, you can imagine your childhood home and assign specific memories to different rooms in the house or drawers in a dresser. This was a technique used by the classic Greek memory masters. One resource I recommend checking out is the Memory Book by Harry Lorraine and Jerry Lucas. These two are memory champions that have recorded their various memory techniques with interesting anecdotes. They go into detail on all these memory techniques and how to best apply them. I suggest reading at least the first 4 chapters and doing the introductory exercise. You can easily lend this book for free from your local library. One final point I want to make is about elaborative encoding and how it pertains to the structure of the MCAT. The MCAT is roughly divided into the subject areas I covered in the last talk, but it isn't precise. The reason is that test makers want to test your ability to relate information across the sciences to each other. For example, a passage that may seem chemistry heavy may also throw a physics question at you. Biology passages can incorporate concepts from physics, chemistry, and biochemistry. While we're taught that these are all distinct subjects, it really isn't the case. As doctors, we can't forget the underlying biochemistry and physics just to focus on the outcomes. It all matters. So how do we study for an all-encompassing exam like this? We relate as many concepts to each other as we can and take advantage of the spreading activation model. In this model, memory is organized into a semantic network of ideas and concepts that are linked together by associations. When a stimulus triggers one of the nodes, it activates the surrounding web of concepts to further ingrain the idea into our memories. We use literary devices like analogies and metaphors to relate seemingly different ideas to each other. So when you study for the MCAT, certain concepts may seem unclear or irrelevant. As you progress through content review and into the practice phase, new information should be slowly incorporated into your semantic networks to make certain difficult concepts click into place. I briefly discussed Anki last time, so I'll just summarize what we talked about. I told you that it's your secret weapon, but what is it? It's a free, open-source digital flashcard program that offers many more features than other flashcard services like Quizlet. Anki takes advantage of the spaced repetition effect we talked about earlier. First, you make flashcards and then you learn them. Anki automatically compiles your reviews for the day and adjusts the frequency of cards depending on whether you were able to recall them properly. We saw in the forgetting curve that it takes several repetitions to solidify information in your memory. This is why I suggested you start using Anki from the very first day of content review, right up until your test day. The more chances you get to reinforce the material, the better your recall will be. Now there's one debate you may have seen if you didn't follow my advice and went on Reddit for study tips, and that's between using self-made or pre-made Anki decks. There are a ton of pre-made decks floating around online that have gained notoriety because they belong to high-scoring examinees. I firmly believe that the most effective way to use Anki is to make your own deck. You'll learn a lot better if you're able to write and format your cards in a way that suits you best. Someone else's cards may be harder to understand. Though it saves time making cards, you won't get a tailored experience without heavily editing the pre-made decks. So try to budget your time to make cards as you review. I'll be going over some of the best practices to making good Anki cards. Unlike mnemonics, there's a huge difference between good and bad cards. There's also a learning curve to using the program effectively, so try to start using it for classes that you're taking or any other subject you may be interested in. There's a lot to learn, so don't feel bad if you can't apply everything in one shot. It's a process. That's all I have for the presentation on memory. My next few talks will be Anki tutorials that I'll release as I make, so be on the lookout for those. Thanks for listening.